So Patrick started doing a scan to sort of get user input, and then I'll be able to print it out. And the next step for Patrick, and we're just moving on because of time, would be to pull this into a function. And so this was like a real big learning moment for me. Is like I could write code in a linear fashion in one function, but then being able to refactor it, that's the phrase you hear people talk about, refactor the code and pull chunks of code into their own functions. It took me a while to sort of get my head around. And so if I want to put this in its own function, I need to have a function name, so func. And what is this one doing is it's kind of getting, how would we describe this? It's getting like a statement about the individual or an identity of the individual, right? It's telling us about the individual characteristics. And so all those, and that's how you name stuff, is you just talk to, and this is from Bill Kennedy, the guy who's sort of mentoring me with Go. You just talk to a stuffed animal on your desk and you tell it what you're wanting to do and you listen to your own words and hear what words you're saying, right? Like I keep saying identity, like, naming this, person's identity or tells me about this person's characteristics. So, I don't know, I think I'll just call mine characteristics or maybe, all right, I like characteristics. That's actually way long. That's too long for Go. Greet. I like greet. All right, we'll go with greet. So here we go. We got greet, and it's a function, and then so that's the basic setup for greet. And then I'm going to put this inside greet. Take all that and put it in greet. And so what is your name? Okay, we get that. We don't pass anything in. We get this all this from the terminal, right? And then here we just print it out. Well, I want to return that, so I'm going to come up here and do string. It's going to return a string, and then I'm going to do right here return and make it print to a string. So I'm going to return a string, and this is printing to a string, so it's going to return all of that. And then I could call greet, and it's going to receive a string when it returns. So I could do that, and then I could do format println string. Cool. That's kind of fun, right? So greet returns a string, which is what I get right here, and then it prints it out. So I think the description was take two arguments, but I didn't specify if the arguments were from a program that calls a function which takes first name and age. Cool, it took it, but from the standard in as opposed to just some variables already in the program. So now I'm going to go run this and change directory, and this is a VV trial. Go run main. So it asked me the name, Todd, and it asked me my age, 44. Todd is 44 years old. Sweet. I'd probably change this so that after it asks me my name, I respond on that line, and then when it scans it in, it adds a new line. See what this does. Take the line off there and add the line here. Let's rerun it. Todd, see the difference? 44. Todd is 44 years old, and I need a space right there. Dude, I'm old. Be dead before I know it. 44. I can use a space right here.
Are you really 44?
I'm really 44.
You are?
Yeah. Are you surprised?
No, I kind of.
No,
I
yeah,
don't know
kind
why I
of.
didn't know.
Yeah, I just act immature.
Keeps you up.
All right, so cool. Good job getting your hands on. I really like that approach, Patrick. That's cool doing the stuff from scan. All right, so we looked at closure, and we looked at, next we'll look at returning a func and callback. So you can return functions. So let's just look at this code and see what's happening. What do you think is going on here? It's kind of a funny declaration, right? For that function on line 5, func make even, func int, what? But if you don't remember that, okay, here's func, and here's my name. It has no parameters, and then it returns a function. Okay, well now I understand that. It's returning a function. We set I equal to 0, and we return, and then here's a function. Right? We return this function, and this function we're returning is func int. It's a function, it's an anonymous function that itself returns an int, and it returns I plus equal 2, and it returns I. Right? So it does I plus equal 2, and it returns I. So it adds 2 to I. So if we come over here and we do next even, make even generator, this here's a func expression. We're setting a variable equal to a function, because when we run this, we get a function back. We get this function, right? And then when we format println next even, when we call this function, we get 2 the first time. Because 0, add 2, and then 2. We call that function again, we get 4. We call that function again, we get 6. Whoa, trippy, right? And this is like a really classic example of closure, because this value I, right, is enclosed by make even generator. So when we call make even generator and we get this function that's returned, that I value right here is persistent, 2, 4, 6, right? It's like, I is remembered by next even. It's hard for me to even describe it and still somewhat wrap my head around it. But do you see the closure that's happening there? The closure is here, makes even generator, closes, this is a function, and it's enclosing this function, right? And that means that anything in this function's scope, any variables, are accessible inside here. It's almost like trickery or something. And so that variable I is always accessible in here. So when we get that, when we get that, first time we call it I is 2, call it again I is 4, call it again I is 6. And then we could do mass even and do it again, and it makes another kind of instance, right? And sets it back to 0 and runs it all again. You can't interleave them, right? If I interleaved them, it got funky. I tried doing that, and that threw the results off.
So tell me again what the next even equal make even generator does.
So what's make even generator return?
It's a function.
It returns a function, and the function it returns is right here. So next even is now equal to a function. So we could, the terminology we learned for that is that's a func expression. It's taking a variable and setting it equal to a function. And so that variable is now equal to a function, which is just, we saw another way of like naming a function. So we could call that, and here we're calling that function, right? And because there's this closure, right, I is persistent. I has a higher scope than just right here. That's a good way to say it. I has a higher scope than just right here. I is declared up here. So when we increment I, right, that's up here. And so every time we call this, it has a persistent state which is higher than the function. Whoa. Thank you, Zeno, for that coding. I don't know.
So
Exclamate. Yeah, whatever. Yeah, gravitas. Coding gravitas. Whoa.
I'm confused. Next even is the function that's being returned?
So make even generator
Yeah.
is a function.
Return a function.
It returns a function. It's this function right here is an anonymous function.
Yeah.
Right? And so when we run this, make even generator, we get this anonymous function back,
Right.
and we set it equal to next even. Right?
Oh, there's next even. Okay. Yeah.
Yeah. And so this next even is now a func expression, meaning this is basically a function, right? We set it equal to a
Whatever
function.
make even
It's by this name.
returns is equal to next even.
Yeah, and then we run it, right? We run it here, and the first time's 2, 4, 6. And I has a scope which is larger than the function, so as we change the value of I, it's remembered. Instead of most functions, you call them, and then it just runs the same code every time, and whatever the variable was, it starts out again at the exact same starting point. No, the starting point keeps going up because it's got a higher scope and it's remembered higher up. That's closure. It's a bit of a mind bender.
Yeah, that can be real powerful.
Yeah, and I'm not totally sure like how do you integrate this into production, and when would you say, oh, I think I want to do closure there just to limit scope. But you can see if I wanted I to be persistent and have a function be able to like increment I, and for that to be, I would need I to be up at package scope outside the function. Well, instead of sticking I up at package scope outside the function, let's put it in a scope which is outside the function we want, we're running, but within another function, right? So we're limiting that scope of I. So that's maybe when you'd start to think about it, because having variables with global scope leads to problems in coding. And so one general principle is like try to limit the scope of your variables. Keep it as narrow as possible. When I first started coding, in like 2002, I loved global. Just like I'd make a variable and I could access it everywhere and change it, perfect. And then it's like, oh, that's not so perfect. Where did that get changed? I have no idea. Why is that so big? What's running to change that?
So you loved it until you hated it.
I don't know. And then I stopped programming for a decade. So returning a func. Pretty much the same thing we were just talking about. So here we have another example of closure. Or what are we calling this? What was this? Returning a func. That's what we're calling it. Another example of returning a func. And so make greeter, right, returns a function. Returns a function. And the function that's returned is right here. This anonymous func. It's a func string return hello world. So a function that returns a string. And like when I first saw this, I'm like, what? Func, make greeter, func, string, return, func, return. I'm confused. But when I started like to map it out like that, it's like, oh, that makes all right. Dang it, that makes sense. Or thank goodness that makes sense. I understand it now. Make greeter, right? Returns the func. So I set it equal to greet. That's my func expression. Then I run it, and it would print out hello world. Interesting to look at greet's type. So greet, if I say, hey, what's the type of greet? It's a func that returns a string. Yeah, you're right. It is a func that returns a string. So that's returning a func. And then we have callback, which is passing a func as an argument. And then your code will later use that function, call back to that function and use it. Anybody have it? I've always sort of struggled with, and this is kind of like just getting a little bit past my edge on learning, but I've always sort of struggled with how to describe callbacks. Anybody else have another description for callback which works for them? Daniel? Mikey? Ruben? Bob? No? So here, what's happening? Func main, it's calling a function visit, and it's passing in two arguments. The first argument is a slice of ints. The second argument is a function. Whoa. And func visit, right? Here's the declaration of func visit up here. So it gets slice of ints and this callback. And so here we're going to range over that slice of ints, the numbers. And for each one we range over, let's stick it into that function. Whoa. It's like you can totally see how that works, right?
No. I'm trying to. Each number in is called. So it's self-calling. It's calling itself iteratively based on the number.
Okay, what is numbers? What's the argument of numbers? Is it this one, the slice of ints, or is it this one right here, the func? Visit has two parameters. The first one is right there. The second one is right here. All right? So the first parameter that visit takes is a slice of ints. So I got to pass in a slice of ints. So when I call visit, I pass in a slice of ints. That's my first argument. Matches the declaration and the parameter that's specified by the parameter. The second argument that this function wants is a function. This could be called anything. I just chose to call it callback. That's not a keyword. So I could have called it C. And it wants a type, and we know functions are types. So the type it wants is a func that takes an int as an argument. So down here, when I call visit for the second argument, I pass in a func that takes an int. And here's my function. Open up the curlies and format print line that in, right? That int. And then close my function right here. And then close my call to visit, right? Closing the paren for that function visit, calling it. So up here, it's going to range over numbers. So we already know if I was just a print line right here, and I ran this, I'd see 1, 2, 3, 4. If I was just a print line in, right, it'd range over those numbers. But instead of print lining in, I'm passing in the numbers here to callback. What is callback? It's that function I passed in. What's the function I passed in? It's this right here, which takes in an int and then prints the int. So I get 1, and then 2, and then 3 and 4. Just a level, it's obviously this isn't practical code, but it's kind of a very stripped, bare bones example of how passing in a function as an argument works, also known as a callback. And I think that's awesome. Because I've been mystified by callbacks for like 6 months. And I'm starting to be like, oh, that's all a callback is passing in a function as an argument, and then you could call that function and use it. Cool, I could pass a function as an argument and then call it when. And there's synchronous and asynchronous callbacks. So synchronous callbacks just happen immediately. Asynchronous callbacks would be like an AJAX where it's listening, and when a certain event occurs, now I run, right?
So you have to add the word callback.
Yeah, and so maybe, no, you don't. That's not a keyword. It can be called anything.
That's the name of the function.
Yeah, that's just the name of the parameter for the visit function. Just like numbers is the name of the parameter of type slice int that gets passed in, and then I could use that. Yeah. So cool. This is real coding.
What have we been doing so far?
I'm supposed to be doing data-driven websites. Hopefully we get to that soon. We're not far from templates and servers. Laying the foundations. You guys will get some good stuff before the semester's over. You'll get enough by the time you leave. You'll be able to do that example I showed at the beginning of class. Oh, let's go get that page and start doing stuff with it. Or let's put a little server and do some templating and, fill in our templates. Func visit takes 2 arguments. Maybe this helps, having those are the 2 arguments. And we pass in the slice events, so that's our first argument. So I took a lot of pain diagramming this out. Does this help anybody? Right? It's pretty much what I just described, but maybe this helps you see it. Func int takes 2 arguments, a slice events, and another function, the callback. And then I pass in the slice events. Cool. And then I pass in, look at how I diagrammed that for you. I pass in func, the callback, as my second argument. And whoa. And the func passed as an argument, the callback is assigned to the parameter just by the word name callback, the identifier callback, and then it gets used. In computer programming, callback is a piece of executable code that is passed as an argument to other code, which is expected to call back execute the argument at some convenient time. The invocation may be immediate as in synchronous callback, or it might happen at a later time as an asynchronous callback. Another callback. Can you explain this code? So we have a function filter, takes in has 2 parameters, numbers, which is a slice event, and callback, which is a function that takes an int and returns a bool, right? And then filter returns a slice events, right? And so when we call filter, we pass in a slice events because that's what it wants. and we pass in a function. This is the callback, and this function has a parameter of an int, and it returns a bool, just like this was specified. And so here's that function. It returns in if returns n greater than 1, so true or false. Right? That's going to return true or false. Is n greater than 1? So now we have a slice, and we have a slice of ints, and that's empty slice of ints. So there's nothing in there. And there's some other more correct word to use, and I'm not finding it right now. And then we're going to range over numbers. And then we and we run this callback, so we're going to get true or false. So is 1 greater than 1? False, right? Because that's what runs. First time n is 1, and is 1 greater than 1 right here? False. So excess, so we skip that, and then we go back to the beginning of the for loop. Is 2 greater than 1? True. So we then append to our slice events. We append 2. Is 3 greater than 1? True. Append 3. Is 4 greater than 1? True. Append 4. And then return that slice events, and then come down here and print that slice events, and it prints 2, 3, 4. Whoa.
So the interesting thing here is that in func main, the argument is giving us the numbers. You're putting the numbers as arguments for the slice.
Slice events right here, yeah.
But when you do the function, it's named up in the original function.
Right here?
Filter, yeah.
Yeah.
That's where you define it, give it a name, and call it inside the function. Whereas down below as an argument, it's just func. It's an anonymous function.
Yeah.
Yeah, that's just interesting.
It is interesting, right? It's almost like a func expression right here that a function is being assigned to this variable identifier.
And down below, you don't need to define it as anything more than an anonymous function. When you make it an argument.
Yeah. It's just an anonymous function right here as an argument. Very good describing that. And good job working on, let me use the precision, the precise words to talk about this language. Because Go is a language that has a language to describe it. It's a language that has its own language to describe it. And a lot of that stuff is just being really precise with programming things. So that's pretty cool with callbacks and returning functions. So if you've done functional programming like Lisp or Haskell, this way of dealing with functions is super common. It's an approach to development. You get used to passing functions around. Go allows you to do that, passing functions around, but it's not the most common way of writing code. The more normal way you'd write code for something like the code above would just be a simple for loop. For loops are easy to understand, right? Like we could have done the same thing here where we just check, hey, is this number greater than that, and then append it to a slice much more simply, right? We don't need all that complexity. This is just sort of illustrating some programming design patterns and what you can do. But again, like I said, and I said this at the beginning when we start out, Go is about writing clean, readable code, even if it takes you a couple of extra lines. Maybe certainly there might be instances where something like this is called for, but mostly just exposing you to the concepts right now. And so Caleb, right, awesome black belt Go programmer, works at Datadog, wrote a book on it. He was like, keep it simple. All right, so I think we'll stop there because that's time. We'll pick up with defer in the stack. We're almost done with this deck. So, are you guys programming? No. When we come to class, we program. You guys want one more problem to work just at the end of class here? While we're all together and I can help you out? Yes?
Yeah, well, I have a GDG on
All right.
meeting. I gotta get to.
All right. See you, Rio.
So,
Great
if you
having you in
haven't
here.
signed up for GDG Dev Fest, 4 folks coming from Google. 4. Like 1, 2, 4 people coming from Google. I don't know if you got that. You need a loop? Do a loop. Iteration? No. So, if you're interested, please sign up quickly. The free tickets that I gave away here are half gone. So, once